So the logic is any object that's got charge is surrounded by an invisible electric field. For this one, we've got a negative 25 microcoulomb charge. It would be surrounded by an electric field, a bunch of arrows. Since it's negative, those arrows would be pointed towards the negative 25. And then we've got a smaller negative 2. Similarly, it would be surrounded by an electric field, lines pointing towards it. In the space between them, the lines are going to overlap. That overlapping is what triggers the force and stores energy in the field. We didn't talk about electric field energy last year, but it's got an equation comparable to gravitational field energy. It's not a vector, so E for energy, subscript E for electric is KQQ over R. Since energy is a scalar, there is a significance to whether it's positive or negative, so we're going to put in our negatives and positives. When we use vector equations, we don't need to put in the negative for charge. We'll just use our brain to figure out the direction. But for work and for energy and these scalar ones, then we will put in the signs. Microcoulomb is 10 to the negative 6. We've got the 9 times 10 to the 9. The one charge is 25 times 10 to the negative 6. The other charge is 2 times 10 to the negative 6. They're both negative. The distance I made up was 10 centimeters, which is 0.1 meters. Crunching that out, we get an electric energy of 4.5, and when we work the units through, we get newtons times meters, which is the same as a joule. That's the first part. Now the second part, it'd be weird to think of it this way, but really kind of what we've done when we push this negative 2 close to the negative 25, it's almost like we've compressed a spring in between the two. If you kind of match this up with spring potential energy topics we tried before, we did a question where you squish a spring and then the spring shoots a toy car. It's kind of the same idea here. It's an electric storage of energy, but it's the same concept. There's a push between the 25 and the 2. As they sit at this position, the 2 wants to fly away from the 25. If we want to figure out how fast the 2 could get to, then kind of like the spring shooting the car, then it's a conservation of energy thing. The electric energy stored in the fields gets converted to kinetic. The electric energy we just figured out is 4.5. Kinetic energy is always 1/2 mv squared. So 4.5 equals 1/2. We have to convert to kilograms, so the mass of 20 grams becomes 0.02 v squared. We've got a 4.5, we've got a half, we got a 2, so we're going to end up with something like 450. Then when we square root that, the speed is a pretty quick 21 meters per second.